Welcome back, 7th grade builders. Today's explainer is diving into one of the absolute coolest parts of robotics, Unit 02, Sensing and Environment Response. Up to this point, your robots might have just been following a strict, pre-programmed path. Kind of like they're totally blind to the world around them, right? Well, today we're going to change that. We are giving your robots their senses. We're going to see how cold, hard plastic and metal can actually start to feel, see, and react to their environment. And that brings us to the main mystery we're unpacking today. How exactly can a robot use sensor data to respond to its environment? Think about it for a sec. Without sensors, a robot is basically just a remote-controlled car. Or worse, a machine on a blind timer. If it runs into a wall, it doesn't know. It just keeps spinning its wheels uselessly. But add sensor data? Suddenly, it can make decisions. It can stop, turn, or navigate a really complex maze. Figuring out how to bridge that gap between the physical world and the robot's digital brain, that's the puzzle we're cracking today.
All right, let's kick things off with Section 1, Sensing the Environment and Input Data.
So before a robot can make any kind of decision, it needs info. In robotics, we call this input data. It's just like us, right? You look around before crossing a street or reaching for a glass of water. A robot needs a way to constantly read what's happening just outside its physical shell, too. This process is called environmental detection. It's basically how a robot uses hardware sensors to grab input data from its surroundings and send it straight to its digital brain. Think about your own body for a minute. Your eyes and your ears, those are your hardware sensors. Right now, your eyes are taking in the light from the screen, and your ears are picking up my voice. Those sensors are sending input data to your biological brain to process. A robot works exactly the same way. Its sensors act like its eyes and ears, gathering real-time data to shoot back to the processor.
Moving on to Section 2, and we really need to talk about this one. It's the great sensor misconception. Okay, when building robots, there's this massive trap a lot of beginners fall into. The myth is that adding a sensor is just a hardware step. Like you can just snap a piece of plastic literally anywhere on the robot's frame. Because hey, as long as it's plugged into the brain, it's going to work, right? Actually, no way. That is totally false. The fact is, sensor placement is directly tied to what the program needs to detect. Let's go back to that human analogy. Imagine if human bodies were built based on that myth. Would you put your eyes on the back of your knee? I mean, of course not. If your goal is to see where you're walking, slapping visual sensors on the back of your knee makes absolutely zero sense. Your placement has got to match your goal. Which leads us perfectly into Section 3, Hardware meets Software. Here's the deal. You simply cannot separate the physical build of your robot from the digital code you write for it. They are two halves of the same coin. Your physical hardware placement absolutely must be dictated by your programming goals. If your code is waiting for a specific trigger, your hardware needs to be physically positioned to actually see that trigger. So let's walk through what you need to master here. First, you've got to identify sensor rules in the code. You need to know exactly what job each piece of hardware is doing. Next, you have to read the specific input data required. Like, is your code looking for a distance measurement, a reflection of light, a physical button press? Third, you'll create sensor-based behaviors, which is just telling the robot how to react once it actually gets that data. And finally, you have to acknowledge the physical limitations of your sensors. Remember, the robot's coding brain is entirely blind without properly placed hardware sensors. You could code the most brilliant sequence in the world, but if you mount the sensor where it can't see a thing, your robot is going to fail. So here's an absolutely crucial rule of thumb. If your program needs to detect an obstacle ahead, your distance sensor must face forward. I know, it sounds ridiculously obvious when you say it out loud, but you'd be amazed at how often we forget this when we're knee-deep in a complicated build. If you write software that says drive forward until you see a wall, then stop, putting a distance sensor on the back of the robot or burying it behind a piece of the chassis makes absolutely no sense. The sensor can only tell the brain what it can physically observe. Let's look at Section 4, Building a Line Follower. Let's actually put this into practice and plan a classic robotics challenge, a line follower. This is a robot designed to just follow a piece of black tape on a white floor. Let's talk through the exact reasoning you'd use to plan this build. Step 1, identify the behavior. What do we want the robot to do? Well, follow a dark line on a light surface. Simple enough. Step 2, choose the correct sensor. We need something that can tell the difference between light and dark. A distance sensor isn't going to help us here. We need a light sensor. Now for Step 3. And this is the most critical part. Plan the physical placement. Where does that light sensor actually go? It has to be pointing straight down, hovering just slightly above the floor. Think about it. If you mount the light sensor pointing up at the ceiling or facing forward at the wall, the robot is never going to see the line.
The hardware placement is completely dependent on the software behavior you want.
All right, wrapping up with Section 5, your next challenge. Now that we've walked through the logic together, I'm passing the baton over to you. I want to leave you with a final, critical question before your next build session. Imagine your new software goal is this. Your robot needs to drive across a table, but it absolutely must stop before it falls off the edge. Based on everything we just covered about input data, avoiding that great sensor misconception, and making sure your hardware matches your software, where would you mount your sensor, and what kind of sensor would it even be? Think carefully about what the sensor needs to see to keep your robot from taking a serious tumble. Have fun with your planning, and I seriously can't wait to see the incredible environment-sensing robots you all come up with.